All right, 4.5, solve quadratic, solve quadratic equation by finding square roots. You've done square roots in geometry, you've done square roots probably now for 2A, but you have to be able to simplify square roots. So those are some properties you use square roots. You can either break them apart or put them together to simplify. A square root expression is simplified if no radicand has a perfect square factor other than 1. There is no radical in the denominator. Okay, so we're just trying to get in as simplest terms. So square root of 80. Okay, and we're going to put these blocks here because add the answer. It's hard to simply click, but square root of 80 is not a perfect square. But 80 has perfect square factors. Now, it does have perfect square factor of 4, and you could do 4 and 20, but you'd also have to break down 20 because it also has perfect square factor. So the best way to do it is just do square root of 16 and square root of 5. Because the square root of 16 is 4, and 5, there is no perfect square factors of 5, so you're done. If you do it the other way, square root of 80 and square root of 4 and square root of 20, a lot of people stop right here, which is incorrect because 20 has perfect square factor, so it's not completely simplified. So you have to go a step further and do square root of 4 again, which is 2, and you end up with the same answer, but it adds another step. So if you can always pick the biggest perfect square factor, you have a better chance of solving it quickly and not making any mistakes and not leaving it as 2 square root of 20. Because that's what I see most often, people leaving it as 2 square root of 20 and not simplifying all the way down. Now, square root of 6 square root of 21. 6 and 21 aren't perfect squares, but if we multiply 6 times 21, then we get, what is that? Why can't I do that in my head? That's 126. No, that's easy. Okay? Why did I get it? So 100 square root of 126. 126 doesn't have any, is not a perfect square. But what goes into 126? Well, you can divide it by 3. And 42, let's see here, divided by 9. 9 and 14 work, okay? So you can break it up into the square root of 9 and the square root of 14. So you have 3 square root of 14 simplified. 14 doesn't have any perfect square factors. It's just 7 and 2. So you're pretty much done after that. C, square root of 4 and square root of 81. Square root of 4 is 2. Square root of 81 is 9. That one's pretty easy because, well, let me go back. I'll erase this. What we can do on C is break it apart into 4 and 81. And that makes it easy. Square root of 4 is 2. Square root of 81 is 9. Just be 2 9s. Okay, so you can break them apart even if they're all in one single radical. You can break the radicals apart to simplify down. Same with D. Yeah, square root of 7 over 16. You can break it apart into square root of 7 over square root of 16, which would be square root of 7 over 4. Square root of 16 is 4. So square root of 7 over 4 is simplified. Because as long as there's not a radical in the denominator, you're okay. You can have a radical in the numerator, and that's fine. Okay, practice those. Rationalize the denominator. Okay, to be able to rationalize the denominator, you can't have a denominator, or you can't have a radical in the denominator. So let's look at the first one. Square root of 5. I'm going to separate it over square root of 2 because you can separate it using those properties. If you multiply square root of 2, and you see it right here, you know, if it's the form of square root of b, then you just want to multiply by it, the same thing, because that'll cancel it out. So what we want to do is multiply by what's in the denominator, which is square root of 2. So on top, square root of 5 times square root of 2 is square root of 10. And on bottom, square root of 2 times square root of 2 is square root of 4, which is just what? 2. So the answer, that's bad, is square root of 10 over 2. Okay. So anytime you multiply a radical by itself, it should just cancel out, get rid of the square root, and just be the number underneath the radical originally. Okay. Now, let's look at the next one. We have 3 over 7 plus square root of 2. Now, if it's in this form, 7 over plus radical, we got to do minus radical. What we're basically doing is difference of 2 squares. If we do difference of 2 squares, we know the middle term would cancel out and we'll end up with no radicals. So since it's 7 plus square root of 2, what we have to do is multiply it by is on top and bottom 7 minus square root of 2. 7 minus square root of 2. So on top we would FOIL. So I have 3 times 7 is 21, and 3 times negative 2 square root of 2 is negative 3 square root of 2. On bottom, we're going to FOIL these two as well. So we have 7 times 7 is 49. We have 7 times negative radical 2 is negative 7 radical 2. We have radical 2 times 7, which is positive 7 radical 2. What's going to happen to those two? And that's why we pick opposite ones. It's called a conjugate. We pick the opposite ones so we know that if we got the same thing, but a plus and minus and switch, when we FOIL, every single time those middle two terms are going to cancel out. So you can automatically skip that step as long as you know that you're multiplying by the conjugate. Then the last part, square root of 2 times negative square root of 2 would be negative square root of 4, which is just 2. Negative 2, sorry. So we have minus 2 right there. So once you get that down, you can take that shortcut. So we have 21 minus 3 radical 2 over 49 minus 2, which is 47. You can just leave it like that, or you can separate it. Either or, it's fine. Alright, solve quadratic equations using square roots. Pretty easy. Basically, there's a bunch of different ways to solve quadratic equations. And you'll be tested, that'll be your first test to solve quadratic equations. First way you learn was factoring. And you can factor when you have a, x squared plus bx plus c, and you can actually, there's factors of c that add up to b. When it's unfactorable, you can't factor. When you have just x squared and you don't have a bx term, you can just solve it like a normal algebra problem. So that's what you're going to do here. We just have an x squared. There's no bx term. So this is the easiest way to probably solve this. Just subtract 5, subtract 5. So we got 3x squared equals 36. Then you're going to divide by 3, and x squared equals 36 divided by 3 is 12. So now we have x squared. We want to take the square root. Take square root. We have x equals, whenever you take the square root, you must have a plus or minus. Okay? So it says make sure you're finding both positive and negative solutions. So you got plus or minus the square root of 12, which square root of 12 has a perfect square factor of 4. And square root of 4 is 2. So you have 2 radical 3. So you can either write it as plus or minus 2 radical 3, or you can write it as 2 radical 3, comma, negative 2 radical 3. And those would be your two answers. Either way it works on this one. Okay, the same process here. First thing I want to do is get rid of the 1/5. So to get rid of the 1/5, I'm going to multiply by the reciprocal, which is 5. So that would cancel out. 5 times 1/5 to cancel out. So we'd have z plus 3. Actually, yeah, multiply by the reciprocal. So we have z plus 3 squared equals 35. Well, at this point, since you have a quantity, to get rid of the square, you have to square root it. So we're going to do the square root of both sides and get z plus 3 equals plus or minus the square root of 35. Now 35 doesn't have any perfect square factors. The only factors 35 has is 7 and 5. So we can just leave it like that, and we subtract 3 on both sides. Now when you subtract 3, make sure that you put that negative 3 in front. That's how it's most of the time going to be written. So it'd be negative 3 plus or minus square root of 35, or negative 3 plus square root of 35, and negative 3 minus square root of 35. So which one is that? That looks like it is C. That'd be right. So that's how you solve when it's a quantity. When it's a quantity, you got to take the square root a little bit earlier than the other steps. Again, we might make these, we might have to do half of these. This is a lot. This is a bunch of them. So ask me in class, we're going to do odd or even on these. Okay, you can use this to find how a modeling dropped object, the height of it versus time and its initial height. So this is the height. The height is dependent on the time and where you dropped it from. Okay, they give you an example of dropping something 200 feet and how each second the feet gets lower, lower, lower. Okay, So we're going to use this formula to solve the next one. It says, for science competition, students must design a container that prevents an egg from breaking when dropped from height of 50 feet. How long does it take the container to hit the ground? So we're trying to find time, because it says how long. The final height is 0, because it's hitting the ground. So negative 16 t squared plus HO is the initial height. Okay, so the initial height in this case is 50 feet. So how can we solve this? Well, we can subtract 50. So we have negative 50 equals negative 16 t squared. Then we can divide by negative 16. What does that reduce down to? We know it's going to be positive. 50 divided by 16. Let's see, let's change to a fraction. So 25 over 8. Maybe we want it, actually, we probably want it as a decimal in this one. So we know that's 3.125 seconds. Or sorry, we're not there yet. 3.125 equals t squared. Okay, yeah, 50 divided by 16. Now we can take the square root of that. Okay, and the square root of that, 3.125, is 1.77 seconds. We don't have to put plus or minus because there is no negative time, so we can just leave it like that. In real world problems, you take that. You just have to understand you don't have to use negative for time. So that is your assignment. Again, we'll talk about the guide practice, talk about the homework in class, and that is it.